Hello and welcome to the last lecture of the course. This one's for chapter 13. Um, Please note that these lectures are on YouTube, so the links will still work. So if you're having trouble sleeping one night, you can listen to me talk about budgets and standard costs. That'll probably help. Just a joke there. So this last chapter deals with the other part of overhead variances. Last chapter we talked about direct material and direct labor. In this chapter we'll talk about overhead, and then we'll talk about how this can be applied to analyzing sales as well, which the book talks about as marketing variances. I wouldn't use the term marketing in that way, but in any event, we'll talk about that as well. So in talking about overhead, remember from several chapters ago, we talked about coming up with a predetermined overhead rate, and that involved estimating what our volume was going to be to have a denominator for that. And there's a couple of different things that we can use in that respect. So if we're looking at determining a rate before production starts for the year, that would be a budgeted rate. So that's what we used when we came up with predetermined rates. So what do we think is going to happen? Now, after production has taken place and we want to have an expression of what did we do, what was the volume, we can do that one of two ways. We can either do that based on standard volume, that's how many units were completed, okay, and then how much was required for each unit according to our standards. So if we completed 10,000 picnic tables, and each picnic table should have required 2 hours of direct labor for assembly, then we could multiply by that and come up with the total volume. Okay, that is the volume that we will use when we're applying overhead. That's really important. A lot of students get hung up on that. So we're going to apply overhead if we have a standard costing system based on our actual level of production, but the standard number of hours in most cases times the units that we did. And then there's actual volume, how many hours were actually worked, okay, which of course could vary from what the standard was supposed to be. In terms of volume for doing predetermined rates, there's one of two ways to do it. There's either what we actually expect to happen in the upcoming year, kind of our best crystal ball forecast of what we think is going to happen, or we could use the normal long run volume, kind of what the factory is built to do. So the book expresses a preference for normal volume over expected volume. The reason for that is expected volume can have swings to it that are related to the economy or other kinds of factors. And if those swings are negative, it can cause you to allocate overhead over a smaller volume, which could cause you to assess more overhead for each product, which might lead you to raise prices, which is what you don't want to do in a downturn. So they seem to favor using the long run average annual production, and that seems to make sense to me as well. So remember when we talked about budgeting, we talked about flexible budgets. So based on how much we actually produce, what the spending should be. You remember back there the y-intercept, so where that angled line is crossing the vertical axis, that's the level of fixed overhead. So even if we produce zero or have zero machine hours, zero volume, that's what our spending will be. So it's maybe the depreciation on machinery in the factory, some portion of our utility costs to keep the lights on, maybe rent for the factory, things like that. And then as our volume increases, there's a slope to that line, and that slope or the angle of the line is the variable portion of overhead. So maybe that's as we produce more, we need more inspectors, or we need more supervisors, or we use more electricity, that sort of thing. So I can find, using this graph, any point along the x-axis there that determines our volume, and I can follow that up and across to determine what the budgeted overhead will be. In algebraic form, we're going to have budgeted overhead, BOH, equals fixed overhead, FOH, plus the sum of variable overhead times the budgeted volume. And the book gave a small example there of if we had fixed overhead of 1,350,000, variable overhead of $14 per machine hour. If we used our expected volume or budgeted volume to be 67,500 machine hours, we could do the math and come up with 2,295,000. I would point out that there is a typographical error in your book that it took me a while to figure out if I was right or they were wrong or whatever. So that, I'm trying to find it here, that is, well, I can't find the page number now. I'm sorry, but it deals with this same example here. So I think they had 67,500 and it should have been 67,400 should have been the correct amount. Oh, here it is. It's on page 566. That's they did their math wrong. So the overhead rate, the OHR is how it's abbreviated here, is going to be our budgeted overhead, okay, at the beginning of the year divided by our budgeted volume. So it'll contain a fixed element and a variable element, and that's our what we called in an earlier chapter our predetermined rate that we use to apply overhead to production as it takes place. So the book uses applied and absorbed interchangeably, so they mean the same thing. But the key point here, I mentioned this a couple slides ago, is that overhead is absorbed using the standard volume per unit times the actual units. Okay, so it's the overhead absorbed or applied as the overhead rate that we've predetermined times the standard volume, which is the overhead rate times the units of output times the standard input per output. So maybe the standard number of direct labor hours per unit or something like that. So we're going to have on one side, we're going to have what did we actually spend for overhead. On the other side, we're going to have how much we applied. And if you remember back several chapters ago, that left us with under or over applied overhead, which is a type of budget variance. So that round number is really not very meaningful. What do you do about that? How do you solve that problem if you've incurred more overhead than what you've applied? What went wrong? So determining what went wrong is really means let's break that variance down into its components so we can say something intelligent about it. So I took what our book gave us and I constructed this chart that is similar to what we looked at when we talked about direct material and direct labor. You notice there's a couple of more one more goalpost now than there was for that previous one because we're going to have 3 variances rather than 2. So just like in the previous, and that's one thing I like about the goalpost model is that it's consistent across all of these different types of spending. So on the far left, we have where's our actual overhead. That's at the end of the year, we sum it all up. What did we actually spend running our factory? The next goalpost in is going to be what our flexible budget formula was at the actual level of volume, so the actual level of parts made, times the actual variable cost, okay, AV. That's going to tell us our spending variance, okay? So that's going to be an indicator as to how well we did controlling spending, okay? So the middle 2 goalposts, you can see they're very similar to each other, but one is the actual volume, so the actual number of hours that were used if we had direct labor hours as our unit of measure, where the next goalpost over, the third from the left, is the standard volume. So it's how many hours should have been used at that level of production. So it's still at the actual level of production of parts, but it's the standard volume for each part. So that's going to tell us an efficiency variance. So how much is a variance due to the comparison of our standard rate of overhead per unit versus the actual rate of overhead per unit. And then the far right side is the applied. So, and again, I mentioned that's the predetermined overhead rate times the standard volume, which is the actual volume of production times the standard hours, as an example, per unit. So that, and the difference between the flexible budgeted standard volume and the applied is our volume variance. So that's how much is due to just whether we produced more or less than we assumed when we did our predetermined rate. So now I've taken the total variance and I've broken it down into 3 variances here. And to be honest, the one that I care about the most and kind of the purpose of doing this exercise is to scrape away how much was due to volume, how much is due to efficiency, and zero in on how much is due to actual spending. If I'm determining whether a plant manager did a good job in controlling overhead, that's the variance that I care about. So I'll walk through each of these three variances algebraically. So the first one, the spending variances, I'm taking them left to right here. Again, that's a repeat of what the top there of what we just showed in the last slide. So the formula is going to be AOH, which is actual overhead, minus from our budget, fixed overhead plus the variable overhead rate times the actual volume. So the actual man hours or direct labor hours per unit times the actual level of production. So this is going to be based on, did we spend more? Did the rent go up? Did we lay off a supervisor and not replace them? You know, those kinds of things. The efficiency variance, again, here it is in algebraic form, and that's going to get at the actual number of direct labor hours per unit of measure, if that's what we're using, direct labor hours per unit of production compared to the standard labor hours per unit of production. So that's going to get at that difference. So it's going to determine how efficient were we at managing our labor, and what impact did that have on how overhead was recognized. Then the last one, excuse me, I have a typo there. It should say overhead volume variance under that bar there. I apologize for that. And that's going to get again at how much the difference was based on the volume of our factory. Okay, the last thing I want to talk about is how to apply this same technique to analyzing sales. And there's two different things we can look at here. So the first thing is, if our sales are different than what we had budgeted, either greater or less than what we had budgeted, that can happen for two reasons. It can happen either because let's say in this case, we sell a single product. It can happen either because we sold a greater quantity or a lesser quantity of that product, and it can go up or down based on the price we charge for that product. So here we can look at actual sales. Again, the pattern is the same here, right? Where we've got actual on the left side and budget on the right side, and then the flexible budget in between there. So our actual sales is the actual quantity times the actual price we charged. In the middle there, I'm going to have the actual quantity times the price I should have charged, whatever my price list was that I based my budget on, okay? So the dollar value between those two amounts is going to be how much of my sales difference is due to my price change. And then when I compare the middle goalpost with the far right, you can see there I'm holding the price the same and looking at the difference in quantity. So how many units did I sell versus how many units did I budget that I would sell? And that'll give me the quantity variance. So here I can break out, did we sell more products but we charged a lower price, and overall that gave me a negative variance or an unfavorable variance? It'll get at that. To add a little bit of complexity to that, we can look at sales mix. So let's say I have a variety of different products that I'm selling that are all at different prices and different quantities. And at the beginning of the year, I've made an estimate. I believe I'll sell so much of this and so much of that at these different prices. So I can add the sales mix to it. So here the formula is the actual prices, and this would be for each product, times the total volume times the mix. And the mix would be the percentage of total sales that are represented by that particular product. And now you can see I've added some goalposts in the middle there to look at the actual mix that occurred. So maybe 25% of one product, 25% of another, and the other product was 50%, that kind of figures. And then I can look at what I believed it was going to be, what the standard mix should have been. And then in the far end, that's my budget. That's what I anticipated happening in terms of prices, in terms of total volume, and in terms of mix percentage. So what that gives me is I've got the price variance there, okay, where my price is higher or lower than what I anticipated. That's the far left variance. On the far right variance, it's my volume related. Did I sell as many units as I thought I would, or was it less? And then that part in the middle there is the mix variance. How much is due to the fact that I sold more of some products than others in a different percentage mix than what I anticipated, right? If customers made substitution decisions, and that'll add up to my total variance. So again, it's really kind of the process of disaggregating or breaking that total variance into its component parts so that you can say something intelligent about that. So hopefully that was helpful. This is a fairly short chapter, although the subject is fairly complex. So when you get into the homework, if you have questions, don't hesitate to shoot me an email and I'm happy to work with you. Thank you very much.